Today's session is Mechanical Systems and Emergency Power. I'd like to introduce our guests, our speakers. To my immediate left is Ed Perez. His career reflects over 30 years of extensive commercial, institutional, and industrial experience ranging from low-rise to high-rise, small to large, state-of-the-art energy efficiency design. He's responsible for all aspects of M&E engineering, design and specifications to constructions review, project management such designs have included universities, fire halls, industrial buildings, hospitals, high-rise rental and condominium buildings, and hotel complexes. In addition, new designs and high-efficiency chillers and boiler replacements. To Ed's left is Stephen Jenner, Technical Sales and Construction Manager at Simco. Stephen Jenner started his career with a passion for working with specializing heating, air conditioning, ventilation, and refrigeration equipment, working effectively with property managers, consultants, board of directors, and realty advisors, dealing with boilers, booster pumps, chillers, and cooling towers, and fluid cooling towers has led to recognition in this field. Stephen has worked with Simco design buildings, installed large-scale projects valuing in the millions of dollars, and has saved owners thousands of dollars per year in operating costs due to boosts in efficiencies. And to Stephen's left is Bassem Sakur, and he's a principal at M&E Engineering with more than 15 years experience in building services, HVAC, plumbing, and energy generators. Bassem is involved in emergency power upgrades projects that include generator replacement, diesel fuel upgrades, underground storage tanks, replacement code compliance, his words, etc. And lastly, at the end is Ken Blasey. He's the Power Solution Consultant for Total Power Limited. Ken is a Power Solution Consultant and is presently Vice Chair of the CSA C282 Technical Committee for Emergency Electrical Power Supply for Building Standards for Canada, and is an active voting member of CSA Z32 Technical Subcommittee for Essential Electrical Systems for Healthcare Standards for Canada. Ken has extensive experience in the generator market in Canada with Generac, Baldor, Kohler, and Onan Cummings brands, as well as custom manufacturing of gensets with Peel engines. Ken has managed municipal projects for Toronto Zoo, Aviva Canada, Brampton Transit, Deutsche Bank, Home Hardware Distributor Centers, Toronto District Catholic School Boards, DND, DSS, and Sick Kids Hospital, MOE, MGS, and many others. Congratulations, Ken. You certainly do a lot.
It just means I'm old.
I believe that's seasoned, since we're all getting old here.
Okay.
We're going to go through this starting with boilers and chillers. And Ed and Stephen are going to speak to that, and then we'll move on to energy generators. We'd like to have the questions held till the end. We have a lot of material to cover, and we'll also have a slideshow at the same time. So without any further ado, Ed.
Thanks, Mark. It's a nice small group, so we'll get through all our stuff. If you have any questions, I think we're going to hold off to the end.
Yes.
But we'll get going on it. We're going to start off with a term, life expectancy and efficiency. Life expectancy is always thrown around, and as owners and operators and managers of buildings, you're shorter? I'm not tall. As you've all heard life expectancy, and I just wanted to go through what that really means. I believe even one of the speakers this morning said 25 years is a big number in our industry that things start to break down. 25 years is a life expectancy number. What does that mean? It means that 50% of the equipment won't make it to 25 years, and 50% will make it beyond. So what I just wanted to make a note of here is if you get a report and it says, oh, it'll last another 5 years to its life expectancy, that just means half the equipment might make it to that life expectancy. Also, energy efficiency. As it starts to approach that life expectancy of 25 years or 30 years, efficiency starts to really depreciate. Usually in boilers, after about 20 years, energy efficiency starts to go down. So replacement has to be on life expectancy, but also energy efficiency, and then also reliability. You have a lot of people living in your buildings, and going without heat in Toronto, or if you're in Winnipeg, even worse, is probably going to cost you an awful lot more than replacing a boiler earlier. So what we're going to do is, there we go, talk about frequency drives, because they're part of the chillers and part of the boilers. In the old days, we used to go, oh, frequency drives, yeah, if you had a big fan, big motors, you could put a frequency drive and save energy. Nowadays, we can get good efficiencies, good paybacks on even 5 horsepower motors. So when you look at your plant and you see a 20 horsepower, 15 horsepower pump pumping chilled water, hot water, it might be an opportunity to save energy by putting in a frequency drive. It also helps in having the motors last longer due to the fact that it has a soft start, and you might get better comfort because you can control the water flows better, you can control the temperatures to the system. Has a slow turnover here. Boilers. There has been, over the last number of years, an influx of high-efficiency boilers and condensing boilers. So I want to touch on that subject just a little bit. It's not new technology. This technology has been in Europe for 25, 30 years. We're late, very late getting into the game, but it's out. Be very careful, though, on what people try to say. Oh, you should have a high efficiency, a condensing boiler, really high efficiency, you can get 95%. Understand where that efficiency comes from. In order to get above even 87%, you have to have condensing boilers. In order to have condensing boilers, what you have to have is you have to have a system that can use low temperature water. So if you had a building with fan coil units, you can use low temperature water, 100 degrees, 120 degrees to heat. A condensing boiler is a very, very energy efficient way of getting it. You'll get even up to 95% or higher by going condensing. But if you have a conventional rental building with the hydronic heating, you're going to need 160, possibly even more, 160 to 180 degree water in that perimeter. Condensing boilers will not condense if you're supplying 160 or 180 degrees. Therefore, just go to a high efficiency boiler that will get you in the 85 to 87% energy efficiency rate. You want to do that because condensing boilers are expensive. So you want to get your best bang for your dollar, and that means that if you can use low water temperature, i.e. around the 120 degrees, 100 degree range, you spend it to get the condensing. But if you don't, if you have hydronic heating, then just go for the high efficiency one, and that will get you your best return. I said 25 years. 25 years, again, is a number that everyone likes to throw out. If you have a domestic boiler, a lot of times that life expectancy drops to 20 years. If you have a heating boiler system that is at around 160 degrees, you might get 30 years out of your boilers. Some of the big boilers might even get 35. But again, be careful. These boilers that were put in 30 years ago started with maybe an 80% efficiency. When it starts to hit 25 years, you're lucky to get 60, 65%. So now you're going from a 65% boiler to an 85% efficient boiler. That's 20% savings on your gas. That could easily be paid back if you say, installed a new boiler at 20 years, you would get that payback within that 5 years, and you wouldn't have the problems with having an old boiler. So you get reliability, reduced maintenance. Obviously, if you change your boilers up front, you get a reduced maintenance cost. The whole trick then again is when you go to replace your boilers, don't just look at your boilers. We talked earlier about pumps, but it's also the piping in it. So be careful about, there's a lot of people out there that will just go out and say, oh, I can replace that boiler for you for X amount of dollars. They just go and just swap the boiler in and out. And all of a sudden we get called in because it doesn't work. Okay, the new boilers, what you also have to do in order to get your 85% is repipe it. Not totally, like we're not talking about ripping out your boiler room and redoing it, but there could be problems with your primary and secondary loop. You don't have one, you just have one big primary loop. So it would be good to design primary, secondary loop. Controls. Controls used to be, again, just like the frequency drives, very expensive. Nowadays, you can get really good small controllers for boilers. A lot of the high-end boilers come with their own control systems, so you're going to get better efficiency and better comfort because you can control your heating better. You're going to have to replace it, so that's where Steve comes in, if I'm not mistaken, and how to go about replacing it.
Yes. So I wanted to talk a bit about the logistics of the construction as far as replacements of, I guess we'll start with boilers. So typically, boiler projects are relatively more simple than chiller projects because boilers are usually, a lot of them are stock equipment. They're waiting somewhere to be installed. So you could get a boiler in 2 to 3 weeks if you really needed one. When it comes to domestic hot water systems, usually you're looking at about, depending on the situation, a 12-hour shutdown will get the new equipment installed and get it back online so that you can't have your building without hot water for too much longer than 12 hours. Otherwise, you're going to have a lot of trouble. Startups of good quality boilers are usually done by the manufacturer the first time. So these are things that have to be scheduled prior. Usually with boilers, another big thing to keep in mind is usually a boiler plant is in a basement or it's on a roof, and you can usually move boilers through the elevator. You don't have to get into cranes most times. If they're underground, they can go through the parking garage, or if they're very large, you could even get into a knockdown boiler that's actually built on site. So that's pretty much for boilers.
We'll move on to chillers quickly. This is the more exciting part. We covered off boilers because of the sort of the high efficiency and condensing stuff, but chillers, I've been around, as my bio said, way too long. I think longer than Mark even.
No carbon date.
Yeah, you're going to have to do it to me. So when I was around, and for the last 25, 30 years, a chiller was a chiller was a chiller, and if it worked, you left it there because it worked at about 0.75 to 0.85 kilowatts per ton. And that, just remember the number. It's an efficiency number. The technology almost stayed the same. The Trane Central Vac, probably if you have a chiller in your building, that's what you got, a Trane Central Vac or a Carrier. They're workhorses. They just lasted forever. Technology over the last 5-6 years has really caught up with chiller manufacturers. We started off with variable speed drives, frequency drives, just like now we can put them down to 5 horsepower. We can also put them up to 500 horsepower on a chiller. Really improved the efficiencies. We got about 30-40% efficiency out of that. Just lately, in the last 5 years, they've come up with the bearingless, oilless chiller, which is as an engineer, as a nerd, it's cool. Basically, you have a very large motor, very large compressor that floats on a magnetic field. So you have no more oil, no more bearings, no more problems with oil migrating into the chiller, which is a huge problem with efficiency. And it's all floating on about 1 or 2 millimeters of a magnetic field. So the friction loss is incredibly little. What happens then is that your efficiency drops down to 0.35, 0.4. So it's half of what it was years ago. The technology, or the way it looks, is the same. The internals are very different. Again, there's no oil in this chiller. The control panel on there, I remember when I started off in the industry, I'd walk up and there'd be knobs and dials and switches and everything else, and I'd walk up with a chiller mechanic and I'd put my hands in my pocket, because if you ever touched one of the switches, you'd blow up a chiller. With the control panels now, I can operate a chiller, you can operate a chiller. It's all computer controlled. If you try to turn on a chiller and the chiller doesn't want to turn on, it won't. If it doesn't sense that there's flow, it won't turn on. It becomes very energy efficient because it can control its frequency drive, it knows its chilled water temperatures. So here we go back to that energy or that life expectancy. Again, chillers do have a life expectancy of 25 to 30 years. What we're recommending our clients do now is take a look at the energy efficiency of it and say, well, we could actually replace the chiller at 20 years, get that energy efficiency, because now you're going to use half your electrical cost. Half is a lot, okay? You know, in boilers, we get very excited about, we get very excited about boilers when we can save another 5%, 7%. In chillers nowadays, we can save half of the hydro. So that becomes a very big thing in that instead of changing it in 25, 30 years, you have to look at the economics of it and then possibly change it in 20 or 22 years if the economics show that you can do it. We have new technology. So many people out there just think that the chiller is the chiller, and it's not today. So we have some good things in energy efficiencies. There's different types of chillers too. Back again, 20, 30 years ago, it was predominantly the centrifugal chiller. That's one there. It's sort of the classic. It is still the classic in the Toronto area, but there are scroll chillers and screw chillers. Each one has its own application for its own building. It's hard to go into right now, but each one has a plus and a minus. Some might be easier to put in, physically smaller. Some are a little louder, especially the screw chillers. You have to be a little bit careful with that.
Less than 5.
Less than 5. I think we're good. What we're going to talk about now, to go back to boilers, there are incentives for saving energy on boilers. There are incentives to save on the hydro for here. So again, once you're thinking of changing boilers, once you're thinking of changing chillers, think incentives. There is incentives from Enbridge, incentives from Toronto Hydro, OPG. There's a lot of places to receive money. You're not going to get the whole installation paid for, but you get money for it, which is better than nothing. We'll talk about some installations.
So from a construction point of view, when it comes to chillers and cooling towers, I think the biggest thing from my side of the business is if you're looking to replace your chilled water plant, you should be starting working with Ed by the fall of the year before. Chillers, they're 12 to 14 week lead times. They have to be purchased, otherwise they will not make it to the site in time. And from my point of view, usually what happens is we end up getting a chiller delivered to site the first week of April, and it becomes an absolute nightmare to complete that job and have that chiller running before the first hot day of the year when everybody starts screaming. So that would probably be the most important part of dealing with that type of thing. And I'd also just like to say that because I'm on the contractor side of things and Ed is obviously on the engineering side of things, I would caution you that when you interview or whatever your process may be when selecting an engineer, you be very careful which engineer you choose, because I've seen other engineers out there and it's very scary what they will actually, if you even want to call it, design you and advise you to put in. I'm not trying to pump up Ed here, but I've done a lot of projects with Ed and his team, and they've all been very energy efficient, high-end projects.
Well, I think we might run over by 1 minute, but we're going to get into just 2 seconds of the cooling tower. It's the sister piece of equipment to the chiller. Don't forget about it. It also dies in 25 to 30 years. The good and bad part about the cooling tower is you can decide to retrofit it. And again, talk to your engineer. Try to figure out what's the most energy efficient on it, depending what you have. If you have the oldest type style, which is the wood ones, you can rebuild it forever. Eventually, though, you get that reliability thing. kicking in. So, just because you have an old cooling tower and you can keep fixing it and fixing it and fixing it, reliability comes into play. There is some increase in efficiencies. Unfortunately, I can't stand up here and say they've invented a new way to cool water, but they have gotten more energy efficient. They're more reliable. The motors have all frequency drives on it. The fill in it is a little bit better, so we lose less water, which is good for the environment. But again, just don't forget about it. So many times we'll get calls from clients and they'll say, oh, my chiller's getting old, I really need to replace it. And I say, what about your cooling tower? And I get that glazed look in their face. I have a cooling tower? Yeah, the big box on the roof connected to the chiller. So please, in your capital plans, make sure that you understand that you got to look after the sister. And then as far as install?
Cooling towers, generally 8-week delivery. Craning is obviously a concern with any cooling tower, depending on the height of the building, where it is, if you have a parking garage, etc. They can be built on site. This year we did quite a few cooling towers that were actually delivered in pieces. We rigged them to the roof in pieces and then we built them. Yeah, just to go on what Ed said, don't ever ignore your cooling tower, because if you don't have a good working, efficient cooling tower, your chiller is no good to you. So.
We just did, I'm Jan with Synergy Mechanical, and we just did one of these, exactly what you're talking about. So somebody put in a beautiful York chiller, and their cooling tower, they can only run the chiller at 41%, I think.
That's a good cooling tower.
Okay, so if you don't really look at your tower at the same time, you're going to have this super sexy chiller there that you're so excited about, and the tower won't keep up with it. So always, like, go to a doctor, get a second opinion from somebody. If someone says, just do the chiller, don't worry about the tower, you probably want a second opinion. Just have somebody go in and take a look at how the two are functioning together. Look at the new technology you're going to be putting in, and then really do a hell of a run around the cooling tower, because they do work in tandem, and you can have this.
Good luck.
The RHB Insider Network is an RHB Inc. production, publishers of RHB Magazine, and the producers of RHB Newsreel.